sure? I think I didn't. Okay, I'll check later. In that case, what do I do? I'm not gonna get paid. Oh, damn. Then I'm just gonna do some teaching somewhere, fake it and post it, isn't it? Class, what's your name? Christ. How can I forget Christ? Hey, that's bad. All right. So basically, it's just calculations. Okay. It's not emotion. Right now, what I'm doing is just, this is not engineering. What I'm doing. Are you okay? I'm just talking. It's just calculation. The ability to calculate. Okay. So we'll just be doing calculations in class. Is that fine? Okay. Not all calculation. Not all. The good news is that it's not all calculation. Okay. It's not all calculation. Online, are you there?
Yes, sir.
Okay, so we continue from where we left off. Do you have any question for me? Even though it's introduction, well, so you don't have to ask questions. All right, so slope staking. Slope staking is where we need to actually tell that this place is too high. Are you okay? Or you're not supposed to cut so much at a certain point. Why is cutting important at all? As engineers, why is cutting and filling a place? Why is it so important to us? Open your mouth so that online can hear you. To make places level. Okay. What really? Any more? To get a gentle slope. Okay. So I think to grade to a particular slope. Are you okay? Let's assume that we really want to have a particular slope. Then we need to decide that we need to cut so much, isn't it? Or to fill so much. All right. So what we can do is that the basic trick is to just use some side rails. I'm planning of developing an app that can actually help. I want to call it the virtual, side rail. Are you okay? Side rail. Virtual side rail. Okay. So if I want to achieve a certain slope, then how do I implement it without using an actual, wooden structure? Are you okay? So there's a way to achieve a slope. How do we make sure that this room is truly flat? How do you do that? How do you do that? How do we make sure that this room is truly flat? Should it be truly flat? Should this floor be truly flat? That's the ideal thing, isn't it? Or we should introduce steps into the flat. How do we ensure that it's truly flat? So if engineers don't know, then the guy who's doing it, he doesn't care. Okay. We go to places where when it rains, this place is not supposed to be flooded at one end. If the work was truly well done. Okay. It's supposed to be just, evenly distributed. In case water comes to this place, the water should not be able to find a particular corner to be flat at one end because it's totally flat, absolutely flat. Is that okay? All right, so how do we ensure that we have a particular slope? Is it okay? Now, how do we ensure that we have a slope of 1:3:1, 1:3? How do we ensure we have that slope on the ground? Are you okay? We will talk about it. Okay? How you're going to achieve that. Okay? All right. Great. What else? We're talking about earthworks, volumes. Okay? Like N areas, calculation of volume using N areas method. Are you okay? There are different methods of calculating area and volume. Are you okay? Have the Simpsons rule. We have, all sort of ways of doing it. The trapezoidal rule. Okay. So these are formulas. Okay. So we take our time. If I come to class, we're in a hurry. Put the formula down. Take our time and see how it's done. Are you okay? All right. So if you have an area. If you have an area like that, How do you measure it? Okay. The engineer should be able to figure out how do I do that. If we ask to find the area of this, we all know from basic principles, length times breadth. No problem. Triangle, what's the area of a triangle? How base times height. Easy stuff. How base times height. Even that one, an engineer is able to implement it in case you have an area which is triangular. Okay, now so it's up to you to now relate the theory to a problem on the ground, okay, and see how you solve it. So the question that you get in the exam are supposed to be like that, practical, and you are supposed to now think about it and say, okay, that is the solution for it. Okay, so earthworks. What about moving material from a site? Okay, do you know that's a huge problem? Yeah, you pay for material to be transported to the site in case you need to fill it. Are you aware? So who determines it? If it's not done well, what happens? There's cost. You pay extra for bringing in material. Is that also on the same project? If it's a road work, okay, and you decide, okay, I'll be cutting from my own project and filling on my own project. What would it depend on? It depends on the distance. So we need to be able to do these calculations and know before we go there, isn't it? Right? So if you want to know who an engineer is, you won't see an engineer doing anything on the site because his work is what done. What is it? What is it? When was the work done? When was his job done? The reason you won't be there saying, hey, move it here, don't go too far. You've gone 20 meters. The reason you won't do that is because your work is done. When was it done? Collins. Christ is here, don't disappoint me. Yes. Yes, that's why it's done. And what was done? The calculation, the design. So we know that this is a number of trips that you'll be doing. Okay, you are like a soldier, right? Malay. So when I come, I want to see you just doing it according to the command, and the command is the design, the calculation. Is that also? All right. So if you get it wrong, then everything that's going on is going to be wrong. All right. But sometimes we know what is right. We don't do it because of other corrupt tendencies, isn't it? So the guy is an engineer, but now you know what I'm saying. Charlie, let's just cut the corners. Are you okay? So cutting corners shouldn't be part of you. It's part of my lecture to tell you to do the right thing. Is that okay? Don't cut corners. Okay. So we want to learn how to calculate volume, but let me tell you something. Volume comes from area. In other words, I want to calculate the volume of a cube. I think I just concentrated here. That's right. Did I take it? I think I took it. Yes. Can you imagine? I'm hungry. I'm hungry. I don't think. I want to calculate the volume of this. Remember, it's always going to come from the area. You just calculate the area here, and then simply say, I have so many of them going up. Are you okay? Then you simply multiply. Thank God, this never changed. Are you okay? You can make money from this. This idea, not this cube. Are you okay? I'm just saying the idea. Are you okay? So more or less what it means is that if I'm able to get a particular area of the section through a road, all right, I say that the length of the road is so much, I simply literally multiply, isn't it? That's the basic idea. Okay, what you can do is that you can work out the average height and then just get a volume. You see how fun that is? Okay, great. So basically, that is that. What is horizontal control? What is vertical control? I think you are not surveyors, but maybe I need to find out if you know about it. I don't think we waste too much time with it. Horizontal control. How do you establish I just want to know. If I don't get to know, I wouldn't know whether I'm just talking too much. Control. Have you heard of horizontal control? Horizontal control. Have you heard of control points?
Yes.
In survey, you done some introduction to surveying. Yeah. So you might have heard about that. Yes. You know it, but okay, now if you haven't, if you are a regular student, you haven't, that will also be a shock. But if you've not done that, you can't do this. Of course, it's okay. So, and then we're talking about horizontal control and vertical control here. Is that okay? I don't think it should become a big deal at all. It's like the pillars that you have on the site. Are you okay? You have pillars on the site. The pillars have numbers associated with the pillar. Are you okay? And then when you set your instrument on it, it means that is the coordinate that you are on. Okay? And then you can now measure to another one. And then you can now start working from that. Why are controls important? Generally, why are controls important? Sad. Okay, after I come to you.
Are you talking about the backside?
Yeah, of course. Once you set up on one control and you now measure to another control, that will become like a backside. And then you now turn to your foresight, and then you start measuring, or you start working from that. If you want to set out this building, you need a control. Why do you need a control? As an introductory lecture, why do you need a control? Why do we need a control as engineers? Why do we need control? Exactly. There's got to be a reference. Otherwise, by the time you finish, you're supposed to put out a building that looks like this. Okay? If there's no control, you finish, this building is not going to look funny. Are you okay? And when the owner comes, just say, that is it, okay? I finished for you. Don't talk. We are from the Ghana Engineering Regiment. Is that not so? Or infantry battalion. Like, let me tell you the truth. The last thing you want as an engineer is to be sacked from a project. And that means that you need to be up and doing. It's not going to be easy. Are you okay? But it will be fun to finish, know that job well done. I can walk about in my tie and say I'm an engineer. Are you okay? Then you call it, hey, engineer. Oh, that sounds good. But engineer, can you just do that for us? Okay? Just put that structure there for us right now. Okay? Don't say you're not a surveyor, a survey engineer. Don't say that. Surveying, everybody's using it now, okay? You can behave like a surveyor for a moment if you do you're a civil engineer. Are you okay? Are you okay? All right. So it's very important that we understand the need for the control, okay? If you don't understand the need for it, then you could be making a whole mistake with the whole project. It's controlling it. The fact that it's called control means that the whole process of the construction is dependent on it. More or less, that's saying that the most important thing. That's what it's saying. It's literally saying that that's the most important thing. So if you are a good engineer, you don't joke with the survey. You don't joke with the survey, okay? If you're a good engineer, even if you are not the one doing the actual survey, you will know that it's being controlled by it. Because you worked out, you need so much, sub-base material, this, blah, 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 blah. Now, where are we going to put it? Are you okay? What's the level, what level should it come to? That's going to mess you out, isn't it? There's a funny story. They put up a structure in London. The whole thing was looking beautiful until one of the windows came down. Then a guy I knew told me that, you know something, I was an engineer on that project. That guy was telling that he was an engineer on the project at the time that it was being done. I said, just stay here, cool. Don't go anywhere else. I'm sure they're looking for the person who said that thing. Are you okay? But now they're out there looking for you. Obviously, they go to the projects, the top bosses. Are you okay? And we all aspire to move beyond just being, let's stay on the field. Are you okay? And now you are telling what should be done based on knowledge. So that is what imparting knowledge is all about, guys. So we do some coordinate transformation. so that you appreciate that coordinates, there are different types, okay? We can have coordinates that are just global coordinates. They're like national. They are coordinates that are just local to the project. Are you with me? So now, once we know that, okay, we are agreed, you say, yeah, there are different type of coordinates, but it's the same place I'm working on. So say, what are you saying? Are you okay? What I'm saying is that it means we can do a conversion. Okay? Let's assume you're working on a project. Sometimes the project you're working on has some historical something to it. There are projects, maybe it's an airport, but there are places that are conserved. You with me? And that data may be in a different system. Why do we worry ourselves with coordinates? Because you see, graphs, I don't know if you enjoy graphs. When you were growing up, you are not kids here, right? When you were growing up, did you like the graphs? That is coordinate system. Are you okay? But the teacher then can't say, just do y, like that's coordinate system. Most coordinate system look like this. All right? We see if there's a change in the coordinate system. Let's say, let me give you a scenario. And I ask very interesting questions sometimes. You're working on a project, West Hill Mall, structure is, everything's going on. All of a sudden, God forbid, it's on the F tremor line and there's been just some shaking. Are you okay? And so the project is now, it's like you went through the project. Are you okay? So at this point, maybe you call me, I call someone, your senior service. I need your help. What do I do now? Because the whole coordinate system is now messed up. How long was the extent of the destruction? You mean you have to start all over again? But it's your knowledge, okay, of these coordinate systems that will help you at this stage. Okay? For Christ's sake, all right? Make sure that you do due diligence. We'll talk about GIS. I don't know why we are even talking about GIS, but we'll talk about it. Okay? Exactly. Those who don't come for lectures, online people sleeping in his room and he's put some toy in front of the camera. All right. So you see, I asked a question about universal transverse Mercator, which is a coordinate system. Coincidentally, I'm talking about coordinate system. So it's okay, I can talk about it. And a student didn't come for lectures. And you went online, he typed UTM. I didn't actually put the full meaning there. So when you type UTM, something can be some motors, something, transport motors. So you can see I've gotten a victim, isn't it? So if you and me, what would you do? A big zero. Are you okay? It's just like give zeros. I don't know why it's like it becomes some cynical people, bad people. So GIS, why do we need it? Because guys, that's the new technology. Things are changing in this world. We are living in the age of artificial intelligence, machine learning, deep learning. You can't be doing engineering the same way you did in 1942. Are you with me? Yes, sir. So let's be abreast of the technology, okay, and know what is going on. Because you can sit behind your computer and start checking that probably your project is being implemented the way, like I said, an engineer or someone will sit in a 4x4 and just walk around in a helmet. Are you okay? From time to time, you need to wear the helmet and go out there and see. Take your tape and measure. Are you okay? But there are times you need to also sit and brainstorm into it and think that projects don't have to be just, you know what I'm saying, small places, some building. Oh, set it up. Oh, the profile board. Okay, that type of work. Oh, we need to go beyond that. Okay. Construct a tunnel to go to Wager Dam. Are you okay? To solve the traffic problem. We don't have to now go and bring a professor from Pennsylvania. No, let me be very, very. This is part of engineering. It's all that we should embrace the new ways of doing things. Research is also done in engineering, please, guys. Sorry, are you agreeing? Okay. So GIS, simply put, okay, the full meaning is Geographic Information System. We will talk, I think I will teach you, maybe I will. But the thing is, GIS has come to stay. Are you okay? It allows us to do a whole of analysis that you can't do as an engineer. All you know is my design, isn't it? But if something is impeding, if your design is not even effective, how would you know? You wouldn't know. Okay? The efficiency of that thing that you built should be of concern to you at a certain level. Maybe your prayer here in this class is, I just want to be an engineer, okay? Maybe this training and education is not about just you becoming that, but going beyond that. Always remember that. If you are here and your thinking is that, I just want to be an engineer, maybe you want to make you more than an engineer. Are you okay? So GIS will help us. If you implement GIS in a grader, it can actually make sure that it casts the right grade all the time, depending on where it is. If you actually put in a global positioning system. Are you okay? So global positioning systems are like the location you find in your phones. Okay. Can you imagine if you have that same chip in a car, your car, in such a way that it could literally detect, are you okay, that there's a tilt in your car? See some of these modern cars, see some of the things that they can do, right? That they know you've sat in and all these things. That's where we are. So if you were building cars in 1970, now you won't be able to build a car again, okay? But the kind of car you build, people go like, hey, what's that? You don't use that again, okay? All right, so please, global positioning systems, every engineer should know it because you could use it to just do setting out on the site. Are we good? Right. Now it works by using satellites. We want to just talk about it in this class during this lecture. We want to just take time and talk about it. Okay. All right. So when we get there, please don't run away. Remote sensing. Remote sensing. So remote sensing means what? You are sensing from afar, isn't it? So these are satellites that have been launched into the sky. Okay. Now these satellites literally they are pointed down to now capture images, to take photographs, images.
So what is different between the uses?
So they all use satellites, but one of them need a minimum of about 3 satellites to locate you. So it's mathematics. So the mathematics teacher can tell you that if you have this, if you knew this and knew this and knew this and omega, gamma, okay, kappa, and this is A, B, C, I can find P. I know what I'm saying. All right, so that's what GPS is doing. So A, B, C are the satellites. So we shouldn't be ignorant. If you use this in your life, think about it this way. Anytime you switch on your phone, you are actually connecting to something up there in the sky. You need 3 of them. And if it's cloudy, then the message probably may not be coming through very well. Are you with me? So if you're ordering for your Uber and they're not getting their position, they're always going past your house, the accuracy has reduced because now it's not able to read because it's cloudy. Are you with me? An engineer should know that. There are some things engineers should know because engineering is about solving problems, complex problems. It's not really about engines, but even though engineers construct design, but you should be able to figure certain things out. Are you okay? And so this knowledge is not, it's okay to have. So we will talk more about it. Are you okay? And so when we go in details, I think you appreciate it more that there are not just 3 out there, there are more, all right? But the idea is for the engineer to be able to obtain the coordinates for a point in question. But the remote sensing is simply giving you an imagery. Okay? But what are the 2 giving you? They are giving you data. One of them is giving you just a pair or triplet of coordinates, isn't it? GPS. The other one is giving you a picture. Which one is even giving you more information? More information. Sad. GPS remote sensing. So which one do you think is really giving you more information? Why? I knew it, that's what I asked. I knew that's what I asked. And you are being honest. I like your honesty. You just guessed. All right. So obviously you are getting a picture. Are you okay? It tells you more than to say, this just one location. Are you okay? Just one thing.
GPS will give you a location.
Yes.
But the remote sensing will give you
literally everything.
everything.
Because it's a picture. In Ghana, what are some of the adages that are used? In Nigeria, what are some of the adages that are used? Your adages are actually telling you, they are teaching you, are learning from your adages. Are you okay? Do you know why I'm saying that? Because the Chinese have an adage. They have an adage. An adage. Oh, because I'm teaching engineering doesn't mean I can't use some words.
You understand
Adage. You know what an adage is? Yeah. So you are more engineers than I am. Have you seen me in bush measuring, my friend? You're not more engineers than I am. Okay, adage is like a saying. Are you? That's quite said. So we will arrest all of you. We allow him to say, right, so arrest all of them. Okay. All of you. Okay, so please, guys, they said a picture is worth 1,000 words. Right there is a lot of what they are saying is that there's a lot of information in a picture done. Okay, right. So we'll talk about remote sensing. Is that okay? Just satellites flying in the air. There are so many of them out there. Don't forget about the world superpowers. So there are countries with their own satellites out there. Okay, there are different missions. That's why people launch satellites. Okay, they launch that some of them were for communication, so that we can, there are areas in Ghana where you can't get internet. Right? But you can get very good internet via satellite. Via satellite. Did you know that? You think MTN has to be everywhere? Even MTN knows it. Are you okay? It's possible to just replace them, then put something else. You get internet. All right. So basically, understand that GPS and remote sensing are making use of what? Satellites. Okay. So GPS is more like what we call the satellite surveying. Are you okay? Satellite surveying. Are you okay? But then this class is not satellite surveying, but we will introduce the topic. All right. Okay, great. We want to also come into the last two topics then. I think we'll just end it there. Hydrographic surveying. Okay. Hydrographic surveying. Hydrographic surveying. So these are all introduction. We are not going to. You want to just understand. If someone says he's doing a hydrographic survey, you understand what he's doing.
Yeah.
Okay. What is hydro means what? So you are engineer, and then says a little water from right? Or a little flood. Just this between here and the mountain over there. It's flooded. Are you okay? Do we have engineers in Ghana? It's flooded though. Water. Now it changes everything. All the things you learn in school. Are you okay? Because in your engineering course, they never talked about measuring underwater. Are you with me? That is why, because Saad always wants to understand why we are doing certain things. Okay? And so I'm gonna tell you why. Did you get a scenario? Let me tell you something. When I'm teaching like this, some of the things I say become exam questions. Are you with me? Did you see that exam question I just gave you? If this place just got flooded at a certain level, what is the height here? Do you know this is not even the highest point? Probably. But this is quite high. It's one of the highest points. Are you okay? Yes. You literally can see. I'm sure if you stand on that, you see the seashore. Okay. What I'm saying, the point is that what if water filled up to this level? All these buildings are going to go down, isn't it? Okay, so in that event, which people do you call? Okay, you call the military, don't you? They have the engineering regiment. You see, but you see, when you call engineering regiment, Ghana Institute of Engineers, you don't put your hand behind it. You join them, don't you? Okay, but anyway, that's why a lot of military people want to be engineers, and then they can probably be direct. Okay, so you have to now start thinking differently, because we're not teaching water in anything that we are doing, are we? So how are you going to measure? Anybody has an idea? Get scuba divers. I want funny ideas, please. How would you be dealing with the situation? It's flooded up to this level, and they've called you because who are they going? I don't call nurses. Are they going to call psychologists, politicians? Don't go to politicians. Don't mention their names. Are you going to call farmers. Who are they going to call? Engineers, right? Okay, electricals, mechanical, no. Likely who? Civil, geomatic. Are you okay? Geomatics are the engineer, the surveyors. They know the surveys. That's why. So this course actually a survey. You have 10 minutes online, guys. I think we're almost done. The 10 minutes we shouldn't finish the introductory lecture. Okay, so basically it changes the dynamics. You can't measure again because yes, what are you gonna do? You're gonna drown. You won't go near it, right? You just be standing there discussing the lady, the woman. Are you okay? What do we do about this situation? You join them. They will even be in front of you. All right. So hydro survey is about using technology such as sonar, which is sound navigation and ranging. You will learn that sound can be used to measure. Can you imagine that? Are you okay? Sound. Because in water, we can't use our total station. It can't work. Are you okay? And even if we had a way of putting the total station under a boat, if you send a signal, the water will just attenuate it. Are you with me? It will attenuate, it will cut it. It can't go through it. Are you okay? All right. So we will learn basics. Okay. How this works, so that you have a knowledge that okay, you become some kind of district chief, something engineer, something regional engineer, then you will know who to employ. The part of this country is people trying to not even know which professional to call. But they send their niece to abroad to go and learn and come back. Nobody's going to take this position. Are you okay? My niece is going abroad 5 years. When he comes back, then we deal with this situation. Is that okay? No, but God forbid. Anyway, guys, so hydro is just a very nice one. The sea is right here. Are you with me? The sea is right there. So I'm even talking about this place getting filled. Now we need to go there as well. How do we reclaim land? Do you know that's engineering as well?
Yeah.
This is why this is here. This is why we're talking about this. Because I've seen people on TV talking about the sea defense wall and sea erosion. All right. And you know what I say in my house watching it? Do you know what you're talking about? Do you get what I'm saying? So do you know what you're talking about? You can be embarrassed. So some things, don't joke with it. It's all right. I'm justifying what we are talking about. So this mine 7 is the last one. Mine 7. Mine 7. Mine 7. Why is it special? Why is it special? This is the last thing, then we close, guys. I'm hungry. I better get some food. Say again. You need to go into a pit, eh? The cash is there. Thank you very much. That's all you need to know. Are you okay? The cash is there. Cash. What it means is that who will even go underground? Are you okay? You on your own accord, would you just say I want to go underground? Because there's something there. Are you all right? Okay, now some of these shafts, they have what you call shafts, like go down. No, there's the surface mining, are you okay? And then you have the underground, and then you actually take it down to it because the gold resource is always sitting down there. And human beings, seriously, I don't know, to discover that there's huge thing down there. So let's devise every means to get it. Are you okay? You understand that? You see what I'm saying? You see what I'm saying? You see that? But basically, you see, it's not safe to be doing that. So how you do it? In fact, the way you do the survey is like that. How do you even get a control down there will become an issue. So we talk about what we call the waist back triangle. The waist back triangle. Waist back triangle. Right? Okay, so a way to now get down there. Remember when you get down there, it's not like, okay, we are underground. Guys, can you see we are underground? Yeah, go and play over here, okay? It's not, we don't do it that way. When you're underground, it's tunnels. Are you okay? Shaft is like, it's like, how do you call shaft? Elevator, the one that we have Lifts, thank you. Okay, and everything is just tunnels. So you just don't have the space to do the things you've been taught. So you have to find a way. Are we on the same page? All right, we touch on that. We're not going to take it like personal. My 7 CV, are you okay? But we just want to introduce you to some of the concepts. I will be giving you assignment from time to time. You will do it for me. It's okay. Even if I'll put it on Google Classroom. Are we all there?
Yes, sir.
Great. So I'll put it there. You do it. I hear on Google Classroom, you can't put a picture there. It's all tests. So it's a question I have to just ask you and then you answer it there. Anybody use Google Classroom here? So I give an answer. It's a forum, it's like discussion, isn't it? You can literally not post like images there. You can attach, like we attach pictures on, WhatsApp or you can even Zoom, you can drop some documents. So let's know the limitation of Google Classroom. So your assignment on laymass should be differentiated, should draw a line between that and Google Classroom contributions. Are you okay?
Okay.
Are we good?
Yes.
Great. So if you go with me, if you just go with me, I think at the end of the day, you'll be scoring very high marks, even though it's face-to-face. We all know the traditional face-to-face exam is more difficult than the actual online. People just go and copy the answer. And then, because they want to run the plagiarism check, they intentionally write with their hand. Are you okay? I mean, there are a whole lot of ways to go around it. And I was thinking that, is there a way you could just let someone sit behind a computer? That someone has actually designed something like that, where so it can tell that you are copying, like as you do the online, it knows that you are trying to cheat. It's there, but maybe it's expensive.
But
Yes.
the one that I know of, they give you time.
Okay.
They give you time, and using that time to go and look for the answer. By the time you come back,
The books are on your down here looking at.
No, but it takes skill to do online exam. It takes skill. The ability to copy and even come and paste it. It's not easy. But some if joke with them online, you score 100 or 100. That's it. Yes. All the best, guys. So this is the end of our first lecture. Next week we are doing circular curves. Is that okay? We won't rush to go into transition curves. We just stay in circular curves. Are you okay? So you are satisfied. Then we move to transition curves. Is that okay?
yes,
Where the speed has to be considered in the design. See, that won't be interesting, isn't it? All right. So we give you speed. I reckon we tell you that, okay, this is the number of transition curves we want. Then you just do some. So thanks so much for the time. And we meet again, same time next week. I'll try and come a bit early.